Hey there, this is Math 7, Unit 5, Lesson 11, dividing rational numbers. So we're going to be dividing signed numbers today. So first of all, let's consider some equations. We have negative 27x equals negative 35. So without computing, is the solution to the equation going to be net positive or negative? In this case here, without looking at it, if I'm going to move this over there, I'm going to end up dividing by a negative 27. So when I have a negative divided by a negative, I'm going to end up actually with a positive solution there. Are either of these two numbers solutions to the equation? Well, 35 over 27 becomes a positive, so we would say that actually that one becomes a solution to the equation. I probably could reduce a little more, but that would actually be my starting point for this problem here. When it comes to finding the missing values in the equations here, it's important to recognize that sometimes you have positives and negatives working together or mixed up or not mixed up at all, and you have to know what the outcome is going to be. So a negative times a positive is going to be a negative solution, and I look at 3 times 4 as being 12. Over here, because I have a positive answer, I need to multiply by another negative number because I'm already having one there. So my negative number that would work in this case would be a negative 4. Negative 3 times negative 4 gives me a positive 12. Here, because I'm ending up with a positive solution, I have a positive number already, so I can just multiply by a regular positive number to have 3 times 4 equals 12. Here, again, a positive number there, so I'm going to multiply by a negative, so that a negative times a negative equals a positive. And finally over here, because I have a negative solution, I'm going to have a negative 3 times a positive 4 to get there. It then asks you to then rewrite the unknown factor problems as division problems. So let's take a look at what that would look like. Okay, I'm going to draw some lines out here. So writing them as division problems, let's take negative 12 and let's divide that by, in this case here, a 4. That could work. And we're going to say it's going to be equal to negative 3. Here we can take our 12 and we'll divide that by a negative 4, and that's going to equal negative 3. This one is a 12, and we can divide it by a positive 4, and that's going to equal a positive 3. A 12 divided by a negative 4 equals a negative 3. And then a negative 12 divided by a positive 4 equals a negative 3. Okay? And so, what we're seeing here is that a negative divided by a positive equals a negative, right? And a positive divided by a negative equals a negative. So when the signs are different, we end up with a negative solution, right? Different there. When they're the same, when it's a positive divided by a positive, we end up with a positive. And we have this is an example of a positive divided by a negative, which we've already done, equals negative. This is a negative divided by a positive. So what we didn't have listed here is you could also do a negative divided by a negative, and that will also be a positive. We didn't have one. We could rewrite this one if we chose to. We could say it's negative 12 divided by the other number, negative 3, and get ourselves a positive solution. So that'd be an example of how you'd have a negative divided by a negative equals a positive there. All right? So when you take a look at the next page, they're really just asking you that same thing to complete the sentences, which is what we just did. Okay? So complete the sentences. The sign of a positive number divided by a positive number, so positive divided by a positive number, is always positive. A positive divided by a negative is always negative. Negative divided by positive is always negative. And then a negative divided by negative is always going to be positive. All right, let's take a look at a little word problem. It says Han and Claire are walking towards each other at a constant rate. Okay, so they're walking towards each other. So one is walking this way and one is walking that way at a constant rate. They meet up and then they continue past each other. So not only do they go this way, they eventually meet each other and then walk past each other. Okay. So as they're going along, they cross each other like so, like that. We'll call the position where they meet up at 0 feet. So we'll call this 0 where they happen to cross each other up at. Okay? And the time when they meet, 0 seconds. Han's velocity is 4 feet per second. So since that's going the positive direction, let's call this Han, and we can say he's going at 4 feet per second. And since this is Claire and it's going -5, we can say this is Claire over here going -5. So Claire is the arrow going this way, and Han is the arrow going that way. Where is each person 10 seconds before they meet up? So like we've done before, we're going to take, for Han for example, we're going to take his velocity, which is 4, and multiply it by the timing we're looking at. Now 10 seconds before actually is going to be a value of -10, because before he gets to 0. We're before there. So 4 times a -10 is going to put him at -40 for the location there, -40 feet. Which makes sense, because if he's going this way, before he gets to the meeting point, he's going to be located somewhere over here, which is in the negative side of the world, right? But for Claire, Claire is going -5 feet per second, and 10 seconds before she meets up, that'd be a -10, right? So here's Claire. So somewhere over here, we can see that value is over here in the positive side of the world. It's going to give us a +50 is where they're going to be. So the question then becomes, when is each person at the position -10 feet from the meeting place? When is each person at -10 feet from the meeting place? Okay, so in this case here, we're looking at where is, when will Han be about here? Okay, and then when will Claire be about there, about 10 feet away from where they're going to meet? So for Han, we know Han is traveling 4 feet per second, right? So we know he's doing 4 feet per second. Okay, so we want to see where he's going to be, and how many seconds it's going to be for him to get to the place where we're at -10. So for him, we're going to do -10 feet, okay, and we're going to divide that by 4 to see what we come up with. In this case, we're dividing by 4 because that's how fast he's going, and that's going to be -2.5 will be his location. For Claire, Claire is going at 5 feet per second, right? Okay, and so what's happening here is that Claire is going to do a -10 divided by a -5 to give us a time be at location of 2, position at 2. So we have -2.5 and 2 is where they are, -10 feet from the meeting place. That is when they're going to be there, that many seconds before. Okay, so there is those two folks there, and that's the idea. Let's move on to drilling down. I don't think I explained that last one very well, but I'm just thinking about it in my head. Sorry. Well, let's move on. A water well drilling rig has dug to a height of -60 feet after 1 full day. Assuming the rig drilled at a constant rate, what was the height of the drill after 15 hours? Okay, so for our drill, it's going at a rate of -60 feet in 24 hours. We want to find out where it was at 15 hours. I can reduce this rate down first of all if I wanted to, just because it's a bigger number. I may not want to play with a big number there. I could, but that is the same as, again, we can cut this in half. This becomes -30 over 12. I can keep cutting it in half to have -15 over 6. I can keep reducing because 3 goes in here 5 times, and 3 goes in here 2 times. We have -5 over 2, and maybe I want to stop it there, or I want to go down and say, well, how much is it in 1 hour? We're going down -2.5 every 1 hour. Now, with that in mind, okay, we can see how far is it going to go in 15 hours, and we can set up a proportional relationship here. So 15 times -2.5 is -37.5 is what our x value is going to be. So at that same rate, 2.5 feet down per hour, it would get down 37.5 feet below the surface. If the rig is running constantly and is currently at a height of -147.5, how long has it been going? Well, we know that it's going at a rate of -2.5 every hour. So we want to know what that hour rate's going to be in order to tell us that we're at a spot of -147.5. So I'm going to divide by -2.5, and -147 divided by -2.5 tells us that it's going to be happening at hour number 59. Again, it's positive because a negative divided by negative is a positive answer there. So using the coordinate grid on the next page, we want to show the drill's progress. So we have some points, right? We have a point at negative, well, that's what our points are. Our points are at 15 hours, we've gone 37.5. So here's 15, and we're going to go 37.5. We're going by 25 here, so somewhere around there at 15. We know that at 60 and 24 hours, we go 60. So 24 is here, and we're going to go 60, so somewhere about there. Okay, that's my 24 comma 60. This is my 15 comma negative 37. Okay, and then we also had, in our case here, we had 59 hours at negative 147, so somewhere down here, right? So that's what my graph would look like. Has to start at 0 because we have to start drilling at nothing. That's where we're going to start from. So I'm going to make it go to the origin here, and we're going to draw this line and look something like that. At this rate, how many hours will it take until the drill reaches negative 250? So again, we can take a look at it and we can see that it looks like, we continue here, it looks like it's going to take somewhere a little over 105 hours. So our estimate might be 105 hours or so, looking at our chart here. Something like that. Again, it's hard to say exactly, but we could also find out for real. We could do our rate, so we can say that at negative 2.5 times how many hours is going to take me to get to negative 250. So when I divide by negative 2.5, we find that the answer should be 100. So I'm off a little bit of my estimation because my graph is not perfect, but that's the actual answer there. All right, let's take a look at tonight's homework and see how you did there. All right, here we go. Finding some quotients to begin with. Positive divided by negative is going to give me a negative answer, and 24 divided by 6 is negative 4. Here we have a positive divided by negative. Okay, so this is actually going to be 0.3 and negative 15. My answer is going to be negative, so I can put that start there already. Move the decimal over 1, move the decimal over 1, and then put it on top right away so I can hold my spot. 3 goes into 15 5 times. So we have 15 there, bring the 0 down, and 0. So we're going to say our answer is going to be negative 50. All right, that's the solution there. And over here, we have negative 4 divided by negative 20. I could set it up as a fraction. Might be easier to look at it like that one this way. That becomes positive, right? So now I have 4 over 20, which reduces. 4 goes into 25 times, so I simply have 1/5. All right, finding the quotients. This is a little bit of review stuff from prior years, but we're adding in the idea of positive and negative numbers. So with quotients, I'm going to multiply the by the reciprocals when we're thinking about it. Okay, so this becomes 2/5 times 4 over 3. That's the reciprocal of that, right? Just flipping it over, or if you want to do cross, you could. So 4 times 2 is 8, 5 times 3 is 15, and it's positive, positive, so we're at positive 8/15. Here we have 9/4 times reciprocal, negative 4 over 3. So negative 4 over 3, this reduces to negative 1 and 1. And this reduces, 1 goes into 3 goes into 9 3 times. So 3 times negative 1 is negative 3, and the 1's just become 1 on the bottom. Here we have a negative 5 over 7 times reciprocal, which is negative 3 over 1. Nothing I can really reduce there, but a negative times a negative is a positive, which is 15 over 7. And finally over here we have negative 5/3 times reciprocal, 6 over 1. We can reduce a 1 and a 2, and negative 5 times 2 is negative 10, and nothing to do on the bottom there. Down below, is the solution positive or negative? We have a positive times a positive will give me a positive. Here I want a positive solution, so I need to make sure this one is a negative, so I have a negative times a negative. Here I have a negative solution, so a positive times a negative, we'll get a negative. And that one's negative, so I want to make sure I mix them up to have a negative and a positive there. All right, gonna find these solutions mentally, and I'll let you do those on your own real quick. Okay, so you can do those on your own. I'm gonna move over to number 5. Number 5, we have one of these on our last one here. Okay, so we think about how much paint we're gonna need. So we have a couple little issues here. First, we have blue is in quarts, green is in cups, and white is in gallons. So we're adding some complexity to this problem here. Okay, so it helps if you remember that if I have a cup, right, a cup, another cup, 2 cups together is going to be equal to 1 pint, right? That's a pint. Now 2 pints, a pint and a pint is actually equal to 1 quart. Okay, this is 1 quart, 1 pint. Here is a cup, 1 cup. And then for us, for our sake here, 4 quarts, little bigger ones there, 4, 2, 3, 4, 4 quarts, so quart equals 1 gallon. All right, so to kind of go back to what you remember from those things there. So it helps we put all these things in the same kind of form. We're going to go ahead and use cups for now because it's just a little bit easier in some ways. Okay, so for our 1.5 quarts of blue paint, okay, so a quart is, right, a quart is here. So if we take a quart and we cut it into, this is our quart, cut it apart, we actually end up having, in our case here, in a quart, it's going to have 4 cups. 1, 2, 3, 4 cups. And we're doing a half, 1.5, so we're actually going to end up with 6 cups. So for our blue, we actually have 6 cups of blue for our original. Okay. For our green, we have 2 cups of green, as it says there. And then for our white, we're doing half of a gallon. So half a gallon means I take my gallon here, I take my quart, and I already know that a quart had 4, right? So there's 4, here's another 4. So I'm going to have 8 cups inside of 1 gallon there. Okay, so that's what I have to start with to make this up. I'm already going to be working with that. So we have 8, 10, this is 16 cups altogether. We want to make, how much we're going to make 100 cups of this mixture here, 100 cups. Okay, so to get to 100 cups, that's a little different than what we had to start with. All right, we're going to multiply by a fraction. All right, so what will that fraction be? Well, how do we do that here? Right now we have 16, and think of it this way. I have 16 cups already, and I need to multiply it by some number in order to get to 100, right? That's what I'm thinking about for how do I get to 100. 16 times what gets you to 100 over here. So the easy way to think about that is it's 100 over 16, because that will cancel out. So let's figure out what that fraction is going to be. 100 over 16. 100 over 16 can reduce to 50 over 8, which can reduce to 25 over 4. And now I have a nice fraction that I can work with here. So 6 times 25 over 4 is going to equal, in our case here, we can reduce this to 2 goes in there 1 time, 2 goes in there 3 times. So 3 times 25 is 75 over 2. Okay. Over here, multiply 2 times 25 over 4. That reduces to 2 and 1. So we have 25 over 2. And 8, we do multiply 25 over 2, reduces to 1 and 4. And 4 times 25 is 2 goes in 4. Yeah, 4 times 25. Oh, 4. That's what it is, 4. Sorry, 4 times that becomes a 2. Sorry, so 2 times 25 is 50. So I'm going to need, in this case here, 37.5 cups of blue. I'm going to need, in this case here, 12.5 cups of green. And I'm going to need just 50 cups of white in order to make that same balance, the same formula. This problem's a little bit complicated, lots of things to do. See if you can play with your you know, your volume measurements for liquids, cups, pints, and quarts, and remember how to make those all go together, and then find out what your scale factor or your constant proportionality is going to be to multiply by it, and then convert from fractions and all those things there. So a little complicated, but that is the way you'd go about doing that one. Okay, or at least one way. Here's a list of the highest and lowest elevations on each continent. Okay, so highest point, lowest point there. And we're going to look for which continent has the largest difference in elevation and the smallest difference. Okay, so largest and smallest. And then we're going to make a display there. So to find that difference, I'm going to do a lot of subtraction to find the difference between these points. All right, so to find the difference here, we're doing some crazy subtraction. And so we do 400, well, I'm going to do, what I would do is I would do the difference and then keep the bigger sign. So in this case here, we're going to keep this to be a positive, right? All these have a bigger value here on this part, the high point, positive compared to that. So we're going to do subtracting on all these ones here and end up with a positive answer. So 4,810 minus 28, or in our case here, we're gonna subtract a negative. And when you subtract a negative, that means what? It means we add. So in all these, we're going to add the numbers. Subtract the negative means add. Subtract the negative means add. So 4,810 plus 28 is going to actually be equal to 4838. Okay. Over here, this sums up together to be 9275. That's the distance between those ones there. Here we have 6050. Here we have 4899. Here we have 6284. Here we have 70 and 65. And here we have 4942. So I get those by subtracting the value there to find the difference, but that means add the opposite. So that's why you add those things together. So which one has the largest difference? The largest difference is the big number here. That's our largest in Asia. And our smallest distance here, looking at our number, we have 48, 48.3, 48.9. Looks like we're going to go with Europe to be our smallest difference there. If we were to make a dot plot or box plot histogram, here's one way you might look at doing that. Okay, and we're going to be looking at it based upon the numbers for our data. Looking at these numbers right here. So you might do something like this, and this is a little just different. All right. So maybe I look for values between, and I have how many continents are 1, 2, 3, 4, 5, and 6, and 7. 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Cool. And then we look at looking at our values here for all the data. We have values that go between negative 2,000 and 0. And so how many values do we have between negative 2,000 and 0? Well, we actually have 7 right there. So I can make a little box plot that goes like this and say I have 7 of those. Between 0 and 2,000, I don't have any numbers in that range. Between 2,000 and 4,000, I actually have, in this case here, 0 of those, right? Between 4,000 and 6,000, I have 1, 2, 3, 4. So we can go up to about 4 here. And between 6,000 and 8,000, we have 1, 2. And then between 8,000 and 10,000, we have just the 1. Okay. And so as a plot, I could look something like that, as that's a histogram technically of what we have. These become our low point elevations all grouped together, and there's that. So you can kind of see that there's a big gap in between, nothing there. But that's why we have high points and low points. That's it for today. Hope that helps you out, and we'll see you next time.